All right, we are back with subject contrast. Now, subject contrast, when I hear the word subject, I think of my patient. My patient's my subject. So we're going to go through a few of these factors, some of which as a technologist you can change and some you can't. That would affect that. So KDP, although it doesn't affect your digital contrast, it can affect your subject contrast. Why? Because KDP, remember, is your controller of your energy and the penetrating power of your X-ray beam, right? So it decides on how powerful it is. And how powerful your beam is can affect how the beam is either attenuated or absorbed, right? Attenuation is the reduction in intensity as it passes through material, what slows it down. Absorption is then the absorption into the body or the contrast media, whichever it is, right? So differential absorption simply means that different parts or different thicknesses absorb at different rates. Don't let that big word scare you, right? If I have low KDP, my beam is moving slower. Low KDP tends to give me higher contrast because those denser parts are going to absorb that slower moving beam and be nice and bright white. When I use higher KDP, there's actually less attenuation. Higher KDP, more powerful. And so the attenuation goes down, the absorption goes down. If my beam is moving faster through, my patient absorbs less. My KDP is also a big player in my scatter. And you guys know scatter is going to be gray, right? Think of your big gray cloud on a rainy day. That's your scatter. Higher the KDP, increased scatter. So I don't really want that. So this is why we can't just jack up our KDP for all of our things, right? Because it has some disadvantages as well. Attenuation by different tissues, right? Attenuation is our slowing down. The things that can increase or decrease attenuation would be the thickness of the body part. The more dense areas of the body will attenuate or slow the beam down more than the less dense. The type of tissue or the atomic number, which is a Z number, right? You don't need to necessarily memorize these, but you guys know that bone is more dense than air. So a lumbar spine is going to be more dense than the lungs, right? The lungs are not going to slow your beam down at all. It's going to transmit really right through, right? And which is why air is black. Bone is dense. It slows that beam down and it's going to absorb, which is white, right? And then my KDP is also my factor, right? Depending on my penetrating ability. Absorption, so depending on the thickness of the part, right, here is my X-ray beam. This picture is just demonstrating different thicknesses and how it will result. So, you know, air is obviously not thick at all. We're going to pass right through. We're going to have the same probably amount of X-ray beam we did at the end as we did the beginning. Thicker the part, less making it through, more being absorbed, more white, right? So your air, your lungs, they absorb the least. Bone or metal, say they have hardware like a hip replacement or something like that, they're going to absorb a lot more. I just wanted to go back over these terms. I know we've gone over these before, but I think this is also helpful when talking about contrast or absorption of things. And so we have radiopaque or radiolucent. And I don't know why, for me as a student, I struggled with this term until someone told me to think of cake with white frosting. So radiopaque, I now think of cake. And I know radiopaque is going to be white. The things that are white are blocking my X-ray beam. So your bone or your metal. Radiolucent, think lucency, are the things that are not blocking my X-ray beam. It's going to, pass through. So your lungs, something like that, they're going to appear black. Now you're all going to think of cake. Some other factors that can make changes to our contrast would be pathology existing in the patient. And this can go back to your additive versus destructive diseases. Your additive diseases that maybe are involving fluid or they're adding thickness to a bone are the ones that we technically usually add or increase our technical factors for. Is it making the bone harder or the bone more white than normal? Or is it a lot of fluid and it's making the image a lot more gray, like ascites in the abdomen is usually a lot of gray, and that's going to make it a lower contrast. Destructive diseases, if it's like osteoporosis and it's reducing the density of the bone and making them look a little bit more gray and not solid white, something like that. Or contrast agents, right? We add contrast agents because there are certain anatomies that we can't see without them. So we need to put something in to be able to see it, and we actually want the contrast media to absorb the X-ray photons so we can see it. There are two types, right? Positive and negative contrast agents. Positive is going to be your contrast media, your barium, your water soluble, things like that. Your negative contrast agent is going to be your air or those CO2 crystals. Obviously your air is going to appear black and your contrast media is going to appear white. So just some, other contrast terminology.